This would be fun to do because, we're in a statistics class, so why not do it this way? Now, I asked you to please hear me out before you criticize. Sound good? All right, this is what I'd like to do for the final exam. Again, you have to hear me out all the way before you criticize, okay?
You must be really nervous about this.
Well, it's gonna be good for everybody. All right, so seven. All right, this is what my plan is. My plan. But hang on, you said you would listen to me throughout before you criticized. Gotcha? So, I will normalize our score in our class. Meaning I'm going to find the average, I'm going to find the standard deviation. Still follow me in this adventure? So that means that if you fall in this category here, I will put a 70% in for you as far as the test goes. If you fall in this range, I'll put an 80% in for you. If you fall here, I'll put a 90% in for you. If you fall here, I'll put a 60% in for you. If you fall here, I'll put a 50% in for you. Okay, hang on. You can't criticize me yet. Okay, so this seems pretty good so far. Agree? Hang on. I'm not done. You can't criticize me yet. Okay, so let's say you fell into this range, but you got a 74%. I will put a 74 in for you. I'm not going to give you the 70. Does that make sense? If you fell in this range, and let's say you had like an 86%, I'm going to put the 86 in for you. Let's say you fell in this range and you got like a 98%, I will put the 98% in for you. But I think for the mass, I think that kind of thing is going to help students.
So you're rounding?
I'm not rounding. I'm going to call what is a modified normal curve. Yeah, you get a 0 on the test, you get a 50%. Okay? Now I strongly would not encourage you to fall in that category because I don't want a normal curve to look like this. I don't want it to look like that. Okay, if the normal curve looks like this, obviously that's pretty top-end heavy as far as scores go. But I think that's what I'll do. So I just, this should, if you have any recollection of a normal curve, as well as if you did fall into the C range, let's say we do this test. This is what I'm predicting. I'm predicting an average grade on this test to be a 68%. I'm predicting that we have a standard deviation of 5. That's what I'm predicting. I can't say that for certain right now because you haven't taken it. But just on observations I've seen as far as the class, this is a prediction made. Now, the prediction might be lower than that. It might be higher than that. If it's exactly that, dude, we're going to go get ice cream. Because that'll be fascinating if I have a good enough understanding of students and how they do in school. So basically what this means is the 68 would fall here. If I go 5 standard deviations or 5% out from that, 68 plus 5 is 73. Down to a 5 less, 63. Did I do that right? Okay. So that's kind of what I'm predicting, which means, and then here would actually be like a 78. Down here would be 5 less than that would be a 58. So basically, that's what I'm kind of thinking the normal curve is. Now, this is, again, my prediction. If I'm wrong, it's very possible. It's really hard to say, make a true prediction, but if this was the case, take a look at this. If you get a 79%, I put a 90% in the grade book.
Wait, really?
That's how a normal curve works. Okay? If this truly was what the class average was and what the class standard deviation was. If this was true, if this is wholeheartedly true, it's going to mean good stuff. Now, where it is impacted a little bit, so in this range here, in this range down here, it is very possible that somebody would get a 62%. Well, I'm not going to put a 60% in for that person that got the 62. I will award you the 62. In this range here, you have that same idea. In that range, you should get a 70%, but if you got a 72%, I will put the 72% in for you for the grade. Right here, if you got a 83% on the test, I'm putting a 90% in for you.
What if you get 63 is not a 70?
If you get a 63, I'll put a 70 in. Yeah. I'll have.
So as long as it's like above like.
If you get a 63% up to a 72.9 repeating forever, well, the 72.9 repeating forever would be a 72.9 that I'd put in for a grade. I would put a 73 in for you because a 73 would then be the 80%. But do you think I think y'all know me. If you got a 72.9 repeating forever, don't you think this guy would probably round it up to the 73, which then would make it the 80%? Okay. Like, I am not going to take on that battle. Like, hey, it's not fair. My kid got a 72.99999, and you said a 73 was the cutoff. Really? Like, I can assure you, I probably made a mistake on the answer key, so your kid probably got it right. Okay? Yeah. You can use as many note cards as you would like. They just have to stay as the 3x5 standard, not 3 foot by 5 foot. People bring in posters in. All right, this is my note card. Let's push some desks away. Yeah. So that this idea, if we truly said 68% was the average, but we haven't taken the test yet, so I don't know what the average is. I don't know what standard deviation is because, again, we haven't taken the test yet. But if this is where we wound up, the person who's in this range, yeah, if you got the 72, I will put the 72% in. But if you got the 68 or if you got the 64 or you got the 63, you're getting a 70% put in. So the thing is, 2.5%, if I kept it as a normal curve, 2.5% of you could earn an A, but also 2.5% of you would earn an F. Okay? But again, I'm not going to let the normal curve, if I have the normal curve as my baseline, what you really want is this. You want to be the relatively intelligent person on this test. So let's say this was our average, this was our standard deviation. Then that means 50 to 55, 60, 45 to 40. Okay, those would be the scores you would get. So if you fell between the 45 and 55, I'm putting a 70% in for you. That's really a top-notch thing. That's where if you're the kid who earns the B on it, you're walking on sunshine because you got the automatic 90% put in for you. Okay, so, but I don't know, because I haven't given the test yet, I don't know what our standard deviation and our mean would be. I have to grade it first. So when you hand your test in to me, you can't ask me, well, what's the curve going to be? Because I don't know what the curve is going to be until after I grade it. But what I was also thinking, just so you all got a little kick out of this as far as humor, because I don't think it'll show you, I don't think we have that turned on for you. It's not going to show you what the mean and the standard deviation would be. I can see it because, I'm the teacher. But let's say I put the 80 in for you. Under the notes category, I will put a C in there. Not because you got a C. I will put a C because you got the curve. But let's say you had an 86%. I put the 86 in for you because if I gave you the curve at 80%, that's not fair. So if you don't have, I will put no. If I put no, that means that you didn't fall into the curve because the curve would have affected your grade. Make sense? So, in my opinion, I think it's a win-win situation. And then after we come back from break, you can ask me about it, saying, "Hey, so I had an 80%. You put curve in there." Okay, that doesn't mean you technically earned the 80% on the test. That means that you fell into your grade was high enough that if I kept the normal curve, it would have hurt your grade by me doing the 50, 60, 70, 80, 90%. Yeah.
What's the test like percentage?
20%. Now we got percent compounded with percent compounded with percent. It's like, wait a minute. Which then leads me to, let's talk about what our homework was. And let's see, I'm gonna sit off to the side to make sure I'm not in anyone's way. And let's take a look at what our homework was. It was 4-2, right? But what did I give you though? I forget. Did I give you the whole thing?
No, just first two.
First? Just the first page. So 1 through 6? Is that right? All right. If you have a calculator, will you please have it out? If you need to grab one, grab one. I know there's not enough for everybody, but that's kind of the thing. So let's take a look at the homework of 4-2. If you're here, I'll put the points in for you. If you're not here, then you better show me the points. And hopefully they're listening to the recording so they can know that they have to do it. Not, hey, I heard you gave everybody the points. Yeah, you weren't there. But I should get the points. You weren't there. All right. So are the outcomes of rain today in Denver and rain today in Centennial independent? Explain why or why not. So if it rains in Denver, does that mean it's going to rain in Centennial? No. So they have to be independent. If you're watching the news and they're like, hey, Denver's expecting 3 inches of snow on Friday, does that mean that this area, Centennial or Greenwood Village or Cherry Hills, should get the same amount of snow? No, they're looking at Denver. They're independent of each other. Just because it snows in Denver doesn't mean it's going to snow where we are. Okay? That would be like say, hey, if it's going to rain in Colorado, you'll get rain. Well, or if it rains in New Mexico, we'll get rain. No, that doesn't mean it'll happen that way. So independent means one doesn't have anything to do with the other. So that's number one. Number two, are the outcomes flipping a coin and getting heads and rolling a die and getting a 6 independent? Does the coin have any effect on me rolling dice? No. Does the dice know about the coin? Dice is going, dude, we rolled a 7, so it's going to be a heads. No. So they are independent as well. So there's two events that could take place. You are an archer. Oh, we're hitting bow and arrows. And hit the bullseye 45% of the time. Ooh. Okay. So this is number 3. So the chance that we get a bullseye is 45%. Okay. Bullseye, 45%. Okay, which is 0.45, agree? Okay. So 4 bullseyes, all on the next 4 arrows. So first off, does the arrow that you just shot, is that going to affect the second one? I mean, someone might say, well, yeah, my arrow could hit the original arrow. Well, let's say we shoot an arrow and you remove it, and then you shoot another arrow and remove it. So there's nothing in the way to obstruct it. So what is the chance we get a bullseye in the next 4 arrows? Well, that's 0.45 raised to the 4th power, or 0.45 times itself. What does that come out to? What's 0.45 raised to the 4th? 0.041. So we have a 4.1% chance that I shoot 4 arrows and all of them are bullseyes. So you're saying there's a chance. Does everyone understand why this converts to this? Basically, all this is multiplied by 100. Okay? B. Missing the bullseye for all 3 arrows in a row. Okay? So hitting the bullseye is 0.45. Missing the bullseye is 0.55, because 0.45 and 0.55 added together is 100%. So this is 0.55 raised to the 3rd power, or 0.55 times itself 3 times. What does that come out to be? Okay, so we will either hit the bullseye or we won't. There's no other outcome. So there's 2 outcomes. Hitting the bullseye is 45% of the time. That means not hitting the bullseye is 55% of the time, because 45 plus 55 is 100, right? Okay, good question. So what's 0.55 raised to the 3rd? 0. What? So we have a 16.6% chance that all of our arrows, if we were trying, you get the one kid. Y'all have that one friend. I got to tell you, I'm that one friend. Hey, we got to be serious. There's always that one friend. Then you got stir up in the bunch. My friends will send memes going, this is all of us, and there's stir up. And what's funny is I have, of all of my friends in Arizona that are my pals, my people that know me to the root, and I know them to the root. Like, we've known each other. Like, I've known Matt Owens since January of 1974. He moved in January. I moved into my house in December of 73. Okay? So I lived in my house for roughly a month, and then Matt moves in right across the street from me. Okay? Matt and I have known each other forever. There are things that Matt could tell you about me that make you giggle. There are things I could tell you about Matt, because you don't really know Matt, but it would make you giggle anyhow. So my network of friends, I have 2 degrees more than all of them. But yet I'm the clown of the group. Because some of them are like, okay, let's act serious. Okay, whatever. Stirrup, don't throw that rock at that car. Oh, I'll throw a rock at a car. I'm just that guy. I don't know why. So obviously, the common sense and the degrees in Stirrup's case have nothing to do with each other. I bet you don't have the guts to throw that entire cheeseburger at the next person who walks in the door. Okay. Woo! Ooh. That's going to leave a stain on that dress. That's me. I'm sorry. Let's see. All right. This is probability at least one bullseye. One bullseye. That the next 5 arrows with 5 arrows, 5 shots. Okay. Now this gets a little weird. I want at least one bullseye. So could I get 2 bullseyes? Could I get 3? Could I get 4? Could I get 5? I can't get 6 because I'm only shooting 5 times. So at least one bullseye. So let's do this. What would the chance be? What is the chance that I have all 5 of my shots don't hit the bullseye? 0.55 raised to the 5th. 0.55 raised to the 5th. Help me out. You guys have the calculator. I don't. 0.55 raised to the 5th power.
5%.
It comes out to 0.05 roughly?
Yeah.
So 0.05, which is 5%. Okay. That is, I have a 5% chance that I miss the bullseye all 5 times. Does that make sense? That means there is a 95% chance. There's a 95% chance that I get 1, 2, 3, 4, or 5 bullseyes. Okay? So there's only a 5% chance that I miss all 5 of them on the bullseye. So that's the only one I want to take out of the mix. And then the term at least one, so I can have 1, 2, 3, 4, 5 arrows hit. So there's 95% that they would all hit. And then letter D. Oops, come on down. Okay. Probability I get a bullseye. I miss. Bullseye, then miss, then bullseye. Then miss in that order. Okay. What's the chance I get a bullseye? What's the percent chance I hit a bullseye once? Yeah, so 0.45. What's the probability I miss? Bullseye? Miss? Multiply all that together for me. Yep. 0.45 times 0.55 times 0.45 times 0.55. 0.061. So I have a 6.1% chance that I shoot like that. Each in a row doesn't know the previous shot. Okay? All right, then we go to number 4. Calculate the probability of getting 10 consecutive heads on 10 coin flips. What's the chance I get a heads? 50% or 0.50. Okay? So if I want to see what that is, 0.5 raised to the 10th power comes out to what? Say it one more time. 9.76 e to the negative 4, like that?
Yeah, it's like 0, 0.
Right, so that's this. That's what it means. And if I multiply this times 100, this will give me the percent. So that means I'll move the decimal twice here. So I have a 0.0976 chance, percent chance, all heads. Okay? Now, here's the silly. We agree the coin doesn't remember. Agree? Now, you could put in talking about game theory, the arrow shot. Agree? And this is why. If I flip a coin, this, you put a coin on my finger and go flip and letting it hit the ground, there's really not too much I can do with the outcome. But let's say they give me 4 arrows to shoot, and then they say, if you can hit 2 bullseyes in any order, 2 or more bullseyes, we'll give you $1 million. Are you trying your hardest to hit that bullseye? Okay, so then you have a monetary value. So that's where kind of game theory goes into it. As far as the coin flip, though, if someone said, hey, if you flip a coin 10 times and you get all heads, we'll give you $1 million. It's really like, how are you going to concentrate on going, ding, flipping a coin? Like, there's not much you can do of this coin flipping in there and falling onto the ground. Okay, you wanted to, you can wish it, you can say, oh, give it luck, blow on it, yeehaw, you have all these mojo things to try and make it happen. But as far as like the actual event of you shooting an arrow, you have skill that's going to come with that shooting an arrow. There is zero skill that comes with flipping a coin. So those are some things as far as game theory and probabilities on that they would be looking at, or that you'd want to look at. If I told you, hey, without the curve, if you earn a 95% on the final exam, I'll give you $1,000. How hard are you going to study for my final? Yeah, everything else, I don't care if I get an F on everything else. Stirrups give me $1,000 to get 95%. Right? So, like, as far as game theory, that you get the psychological part of that. Okay, no, guys, that's nothing else on the table. So if you come and get a 95%, don't expect money from me. I'll give you a fist bump, but that's about as far as we go. Okay, it's like Stirrups recorded. It's at 27 minutes in. You said you're giving us $1 million. Number 5, calculate the probability of flipping a coin 10 times and obtaining 5 heads in a row, followed by 5 tails in a row. 5 heads in a row and 5 tails in a row is going to be the same thing that I go with, because it doesn't know. It's a 50-50 shot either way. It's the same idea. Okay, so that's the same as above. Okay, number 6, assume that 35% of the U.S. adult population has type AB blood. 6 people are donating blood, are tested for blood type. Calculate each thing. So we have 0.35%, or 0.35, you have AB, 35% AB blood. Okay, what's the probability? They have 6 ABs all in a row. It's 0.35 raised to the 6th power. Okay. And then what's the chance that all 6 are not type AB? It's just going to be, you can do it 2 ways. You can go 0.65, because 0.65 plus 0.35 is 1.0. So you could do that. Or you could go 1 minus your 0.35. So either way is going to work. And then what is probability? At least one type is AB. It's going to be this. So you're going to go 1 minus 0.65 raised to the 6th power. That's the chance at least one would be type AB. So, do what? That should be 0.35 to the 6th. That's a really bad written 3. All right, so just think about, there's probability, and then there's something that's called game theory. Okay? So, let's see. Broncos fans. Okay? Who do the Broncos play this week? Lions? Okay, Lions have a pretty cruddy winning percent right now. So what would cause you to bet on the Lions to win against the Broncos? Like if I said, hey, if you bet $1 on the Lions to win 1,000, would you choose to do it? Yeah, because the game theory part of it, you have a monetary value. Like for me to bet $1 to have this small chance to win 1,000 is pretty good. But what are other things that take place? Think about the Powerball. So the Powerball starts out at a certain amount. And then if nobody wins the Powerball, then the Powerball jackpot becomes bigger. If they don't win the next week, it becomes bigger. And it gets bigger. The more often somebody doesn't win. Can someone look this up for me on your phone? What does the Powerballs start at? What's the jackpot for the Powerball?
Right now?
No, just any, like what would it start at, guaranteed?
40 million.
Is it 40 million?
Yeah.
40 million. And how much do you have to bet for the Powerball? I don't know. How much do you have to bet for on the
They
Powerball?
decided last week to reduce it to 20 million.
Wow.
So
it's now 20 million?
it's now 20 million.
Okay. How much do you have to bet on the Powerball to get one ticket? I don't know this. I don't bet.
$2, minimum $2.
$2? So are you willing to try and bet $2 to win 20 million? That sounds pretty good, right? What's $2? But a lot of people choose not to bet right now. When did they choose to bet?
When they're done.
Yeah. I might bet $2 when the Powerball's up to, $500 million. Right? Because let's face it, a $2 bet to get me $500 million, that's worth me edging it. So the likelihood that somebody or some computer will pick the first, pick the right combination of numbers and the Powerball, it could take place. So the more and more people that are betting, the more and more likely chance that somebody will discover that. Are you that lucky person? Boy, that's kind of cool if you are. There was a girl in my neighborhood named Monica Thomas. Arizona first instituted the state lottery in 1985, I think it was. Might have been 86. Monica Thomas's parents, and it was only, they started out for $1 million. That dollar won $1 million. Her parents won it. And then, 2 years later, they won it again. Was it because they were good at picking numbers? No, they had just the same chance of picking the number combination as anyone else. But it was like a weird fluke. Like, oh my gosh, the Thomases, they won $1 million. A couple years later, oh my gosh, they won $1 million again. That's kind of cool. Especially for them, because hang on, I gotta go back there. All right, so let's see. Alec never made it. Aaron's not here. Nicole. Oh yeah. Did I miss anybody? No, we got everybody. All right. So let's go back to. I want to hit the study guide a little bit more, but I still want to teach. Let's take a look at 4.3. God, I'm sorry. This pinch thing in my back is driving me crazy. Let's talk about dependent probability. Let's see. Actually, let me change it a little different. That should work. Yeah. So today, I'll probably have tomorrow just as a review day, and then Thursday we will do the contingent tables, and that's what I saw up to was on the final. All right. Oh my gosh, I want my arm to be better. This is driving me crazy. All right, so this is 4-3. 4-3. Dependent probability. Dependent probability involves multiple events in which the outcome of the first event changes the probability of the second event. The multiplication principle still applies, but the probability needs to be recalculated after each outcome. Okay. Let's go with a deck of cards. We have 52 cards in a deck. You have hearts, which are red, diamonds that are red, clubs that are black, and spades that are black. Okay? Each, in a deck of cards, you will have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay? So I want to know what the probability of drawing 2 kings without replacement. Okay? This means this. I have a deck of cards. How many kings are in the deck of cards? 4. So I have a 4 in 52 chance of pulling a king out on my first one. So I have my cards sitting down on the table. It's no longer in my deck. How many cards are in my hand then? 51. If that first card was a king, we have it down, we have it face down, so we don't know yet. But if it was a king, how many kings would theoretically be back in the deck of cards? 3. All right, 4 divided by 52 times 3 divided by 51. Put it in parentheses. Go parentheses, 4 divided by 52, parentheses, times, open parentheses, 3 out of 51, close parentheses.
You want it as a decimal?
Sure.
Well, I'm asking because I got 1/3.
Oh, it comes out to 1/3?
Yes.
Exactly.
Well, I reduced it. It was 12 1/3, 2,652.
So it came out to 1/3 when you reduce it? Ooh. I think that's off a little bit. Let's try it. Let me bring this up real quick. I'm going to go here. Go here. Let's just make sure we did it right. Bring this up. Come on, baby. Open up. There we go. Close that. Okay. 4 divided by 52 times 3 divided by 51. Okay, I'm not replacing the deck. So that's what it comes out to, which I could do this. I could go math, fraction, and change that into, it's 1 out of 221. Yeah, it's okay. So 1 out of 221. So what's the probability I pull a king, and then I put it down on the table, and I pull another king? 1 out of a 121. Oops. 1 out of 121. So that means that 120 out of 121 tries, you won't pull a king and a king. Okay? So dependent probability, the probability changes because you're not replacing back in. Now, if I said, hey, probability, I want to pull a king, and then put it back in the deck of cards, reshuffle it, and pull another king, I replaced my card, so it's 1 out of 50 or 4 out of 52 times 4 out of 52. So that changes things a little bit. So this is first one's without replacement. Oops. If I put my card back into the deck of cards, it goes from a 1 out of 221 chance, where I didn't replace the card, to a 1 out of 169 chance when I replaced it. So you have a little bit better chance of pulling a king, putting the card back into the deck of cards, shuffling the deck of cards, and then pulling a king again. Okay? So replacement is here, not replacement's here, meaning I didn't put it back into there. Let's see. They have one that talks about, let's say you have 6 freshmen in a class, 5 sophomores, 4 juniors, and 3 seniors. What do you call the class? Not as fun as you would think. It's a lot more fun having all seniors. So you'll pick 3 of them to give a presentation. What is the probability that all 3 chosen will be freshmen? So first off, let's total this up. Is it time to go? All right. Do me a favor. Try. Where's 4.3? Try. Try this for me. Try 4-3, which is page 207. Why don't you try 1 through 8? Good enough?